How do you calculate delta H? Well, there's three ways. One is the way I'm going to show you right now. I call it the rearranging equations method. Then there's another way, which I'll show you in the next video. And the third way is something that we do in AP chemistry or college chemistry. It's not hard, it's just a different method. So in this method, you're given a final equation, like this one. And we want to know what is delta H for this equation. See, we have resources in the back of our book that list all sorts of H values for given equations. Usually they're what we call formation equations. Like, look at this first one. Oxygen and F2 make up OF2. So we have these, but we don't have delta H for that particular equation. So what we can do is manipulate these given equations until we get the equation we want. And once we do that, then we just have to simply add up these H values and you get your answer. But I'm going to start with an easier one first. This one's a little bit more simple. So how do you go about manipulating the equations? The first thing you want to look at is where is everything? Do you notice how CO2 is a reactant, but right there it's a product? So we're going to have to flip this equation. And that just means literally take the products, make them reactants, reactants become products. When you do that, you change the sign on the delta H value. So we know we need to flip that one. H2 is right there, H2 is right there, that looks good. Oop, we need water gas over here, so we're going to need to flip this equation as well. And then the other thing you want to look at are coefficients. Well, all of these have a coefficient of 1, and none of these have a coefficient we need to get rid of, so we should be okay. Always rewrite everything. I know it requires a little bit of extra time, but it really is worth it. So I'm going to flip this first equation. And again, what you do to the equation, you do to delta H. So this becomes positive 283.0. We're going to leave this middle one. So I'm not going to change it at all. Do you notice how I also like to write it to where all my arrows line up? I think it's just easier to see the reactants from the products. And then we're going to flip this last one. So water liquid goes to water gas. And that is going to make us, oops, I didn't write that one down. We're going to have to change the sign on that one. So these two become positive. So what you want to do is you want to see, do you get the equation you wanted in the beginning? Well, anything that is on the left and on the right can cross off. So let's go through that. Cross, cross. Liquid water crosses off. And so what do you get? You get CO2 plus H2. See those right there? That's what's left. Makes CO and water, that's a gas. Now go back up. Is that what we wanted? Up here. Sure looks like it. So as long as you get the correct equation, all you have to do now is add up these manipulated values. And I already did that. And when you do that, you get positive 41.2 kilojoules per mole. Now, something else you need to know is, what does that mean? When delta H is positive, it is endothermic. Energy is going into the system. Something you need to know. All right, let's tackle one that's a little bit tougher. So again, the first thing you want to do is everything on the correct side? Well, I need ClF3 there, and it's right there. So I need to flip this equation. I need ClF here. I'm good there. But do you notice there's no coefficient and there is one here? That means we have to divide this entire equation by 2. And the other problem, I am just guessing, is that we're going to need to flip this one. Do you see how the F2 is right there and over here it's product? So let's flip this one, and coefficient of 1, coefficient of 2, divide it by 2. So we got a lot going on here. So this first one we're going to flip and divide by 2. So F2 plus 1/2 O2 makes OF2. And then you're going to want to flip the sign on the delta H and divide it by 2. And I've already done the work, so I'm going to skip you guys having to listen to me do the calculator. The second equation, we're just dividing by 2. So ClF plus 1/2 O2, 1/2 Cl2O plus 1/2 OF2. Again, divide your delta H by 2, you get 102.8. And then we're going to flip this last one. So 3 halves OF2. Don't you just love fractions? Don't worry, they're usually not that bad. They just look scary. Don't panic. And then the delta H over here is going to be negative 266.7. So as long as you get the equation you wanted, we're good to go. So let's see what can cross off. Well, it's kind of ugly, isn't it? That for sure crosses off. The OF2s, this is 3 halves and this is 1. So isn't that going to give me a half? I feel like I'm messing up here, you guys. Oh, look at that. Wait, there's another half there. A half and 1 is 3 halves. 3 halves, so they all go away. All right. I was getting worried there. Then we have, that adds up to 1. There's 1, so those all go away. All right, so what's left? F2 plus CLF makes CLF3. Is that what we wanted? Hey, yay, we did it. So now all you have to do is add those numbers up, positive 24.7, positive 102.8, negative 266.7. Use a calculator. Do yourself a favor. And you get negative 139.2. Remember, sig figs is place value. They all go to the tenths. You go to the tenths. Kilojoules per mole. Now this delta H is negative. What does that mean? It is exothermic. In other words, energy is being given off. And that is one way to calculate delta H. I like to call it the manipulating the equations method.